Hello, Damon Mercier Solutions. Today I want to take a look at Chia, which is a cryptocurrency that's based on proof of space. It's currently growing at about 1 exabyte per day. As we can see here on Crypto Explorer, it's currently 21 exabytes of space being used. We can see that it is actually a cryptocurrency and it's based on proof of space and time. The aim of this is basically an alternative to energy intensive computing, but it basically requires lots and lots of storage. Now, as a company, we specialize in storing on optical. We use various technologies that operate using a standard optical disc, such as a 128 gig Blu-ray disc. As you can sort of see here, this is a standard drive that would fit in an optical disc attached to your computer. We actually have robots that move these in and out of drives. So what I want to actually do today is take a look and see whether this can actually work with Chia and whether it's actually viable at scale. We also use Sony Petasite, which is basically an optical cartridge that contains 11 discs. Each disc is 500 gigabytes. So in a cartridge you get 5.5 terabytes. Actually got a demonstration cartridge here. If I open up, you can see it's got all the discs in there. Normally you wouldn't never open this. The robotics do that. So let's dive in and take a look at what the plan is. So what we're going to do, we're going to jump in. We're going to actually test the optical BDA with Sony and with a Jukebox. Quick demonstration here of a Jukebox and what they are. We'll then look, will it work at scale? And quick spoiler, it won't work at a large scale. We'll then cover the actual benefits of optical, where you'd actually use it for cold storage and look at the numbers and how they work. So let's jump straight in. Okay, we're connected to the server, which has got the nets on Jukebox. This is a mechanical jukebox that moves standard 120mm discs. So in this case, 128 gig discs. You can see the robotics are directly above me. And if I go to my computer, we can see we've got this drive Z, which is a virtual drive Z, which is a representation of this jukebox. This is provided by the Point Jukebox Manager software. And in here I've got a disk that I've already recorded a plot to. If I do a properties on here, you can see it's using 104.7 gigabytes of the 115 gigabytes. And we have a single plot on there on the disk. Quick overview, this software turns that device into a disk drive and handles the robotics moving and the loading of disks. So if I go into the Chia folder, we can see I've got the one plot there. Now, if I change over here to command prompt, I'm actually in the Chia blockchain app and in the resources. In here, there's a command called Chia plot checks. This will actually go and do a proof of work on a plot. So if I now run this command, we'll see the Jukebox actually go off. And you can see it's now loading the disk above me. It's taken that into the drive. The drive's now loading. And it's going to basically identify the disk, and we'll see the little green light to the top right under the drive start flashing when it starts reading the actual proofs of space. Just take a few seconds. Okay, we can now see the drive's reading. It's reading the plots. We're actually doing 5 challenges here. Let's take a few seconds to complete. As you can see already, the time this is taking, we would not be able to respond in time to the Chia network requests, so this won't actually work. Interestingly, if I now run this a second time, you can see the return is instant. Now, the reason for that is the Point Jukebox Manager software has actually cached the blocks that were read by Chia. But unfortunately, this won't help us either, because the Chia network will request random blocks from the file, So unless we cache the entire disk, which we can do, it won't actually provide that same performance. So again, if I run this again, it's instant, because this is requesting the same proofs. Okay, let's jump over and we'll have a look at the Sony library with the ODA. Okay, so connected up now to the server, and you can see above I've got the Sony Petasite library connected, and this has got the File Manager 2 software running, which again makes this appear like a big disk drive. So we can actually see here we've got the library in various cartridges. Then you can see we've got 2 cartridges in here, and if I go to my computer, we get this drive letter drive X, and in here I've got 2 folders which represents the cartridges in the ODA library. And on cartridge 002 I've got one where I've got a plot, which you can see is again 106 gigabytes. So if we drop into a command prompt here, I can run the Chia plot check M5. If I run this, you can see that's completed already. In fact, if I was to put in here and say 99, have this run through 99 proofs, again it will see it will go through and complete this again in a matter of a few seconds. So you can see there it's gone through and done 99 proofs there. However, this all appears to be great and will work perfectly for Chia, but the reality is this won't actually work because of the way this is caching and the fact that the disk is already loaded in the drive. Doesn't give a true representation. I think if I create a new file on here, demo test, close, save. What we should see in a few moments is the ODA library will change the cartridges over. So again, if I run this check with just the default, you can see this returns in a matter of a few seconds here. Okay. So we can see the robotics now is actually going to change over the cartridge here. You can see it's actually going to pop one away. And we'll see it will load the next cartridge there. So it's, you can get an idea of robotic change times and ultimately why this won't actually work, which we'll look at in a minute. You can see that's now loaded that other cartridge into the drive. Okay, we'll drop back to the whiteboard and just take a quick look at the numbers and exactly why this won't work. Okay, so we've seen, looking at the hardware now, how it works, what it does, and that. But let's look at the actual benefits. So, the optical media is rated for 100 years. A hard disk, we might expect it to last 5 years. A cartridge or disk, once it's stored on the shelf, uses 0 power. We cannot delete the data or change it. So this actually has a barrier against administration error and ransomware. If we're using the Sony optical media, it actually includes parity, which gives a bit error rate of 10 to the 24, which is an industry leading level of errors on writing. For example, a hard disk is 10 to the 15. So in numbers, that means every 25 terabytes versus 1.25 zettabytes compared to optical. Enterprise RAIDs do have error checking built in file systems such as ZFS that actually detect these errors and mitigate them with the hard disks. So, do the numbers make sense? Let's look at the cost. So the cost for a cartridge for ODA is about $200. Therefore, 185 cartridges, which would give 1 petabyte of storage, would cost about $37,000 versus a hard disk costs about $30,000. So we can see already the media cost for the optical is a lot more expensive. However, we'd have to replace the hard disks in a 20-year period 3 times. So we'd have to buy 4 lots. So the cost of the hard disks over a 20-year period would actually equate to $123,000. So significantly more than the optical. This obviously assumes that the data is static and not changing. So the other big consumption is power and cooling. So the ODA, the robotics, use 179 watts, and each drive uses 105 watts of power. So in a 2-drive system, we'd be using 389 watts, and that's the same no matter how big the system's scaled out to. And the Petasite system will scale out to 2.9 petabytes in a rack, consuming 389 watts. But again, if it's idle, not being used, it uses a lot less power. Whereas hard disks, you would normally keep them spinning all the time, particularly for archive systems, because spinning them up and down uses a lot more power and also puts a lot more stress and wear on the motors and that in the drives. So they are continually using, on average, an 18 terabyte drive will use about 7 watts of power. So 56 drives would consume just under 400 watts of power. In addition to that, you've obviously got cooling. With the optical system, there's very little heat generated. So let's look at scaling. So does it work at scale with optical? The answer is no. So let's go through the limits as why. Main limit is due to the limits of the robotics to move the cartridge in time. So with Chia, we've got to return the results within 60 seconds, which means we need to load the cartridge into the drive and then read 30 various random parts of the plot to show the proof of space. With both of the optical systems, the robotics are going to take between 10 and 30 seconds to load that cartridge. Obviously with the Petasite, if it's a full rack, it may take slightly longer than this, especially if we've got to return the cartridge first. And then obviously we've got to read the data. So 1 petabyte would equal 10,341 plots using a K32 plot, which is about 106 gigabytes. Now, on average, each plot is accessed 18 times per day. So throughout a day, that would equal 186,000 requests. Now with the robotics, if they take an average of 30 seconds to serve each request, we can serve a maximum of 288 requests in each day. So you can see from the robotics, we cannot physically do this. And this is actually more than cold storage. This is nearline or almost instant access storage required for Chia. However, it is only 185 cartridges, which does mean we've got a 2 in 185 chance of it not moving, or if we have more drives, we can bring that chance down. But again, it's still not going to get anywhere near the requirements to serve 186,000 requests during the day. Obviously, we could, with the ODA, look at using a K34 plot, which is 429 gigabytes, and that would actually fit on one of the 500 gig pieces of media quite nicely within a cartridge. Though the size of the cartridge is actually transparent and the ODA will span across the discs. So we're not actually restricted to 500 gigs, we can actually write 5.5 terabytes to a cartridge and even span the cartridges if we need to for bigger files. However, even with the larger plot size, K34, it would still be 46,000 moves. So again, it's not viable. Okay, thank you for making it to the end of the video. If you've found this useful, don't forget to like and subscribe to the channel. And if you want to see more, perhaps looking at tape with Chia, which won't work, and why it won't work, comment below, let me know, and we'll put together a video on that. Thank you.